Hello, my name is Nikolay Komitov. I, from University of Technology, Plovdiv, Bulgaria, I will present our paper, Thin Layer Drying Modeling of Red Beet using experimental data, pH kinetics, and digital monitoring. Introduction. In process drying, measure in the product is removed by evaporation, and heat and mass transfer occurs between the product and the environment. This process reduces of the total weight and volume of the dried product, which in turn leads to lower production costs for packaging, transportation, and storage of the product. The dried product has a longer shelf life than the fresh product. The cost of the drying process can reach up to 16% of the total energy cost. Data can be used for analysis and to create a model. Description of the existing installation. Figure 1 shows 3D model of the dryer obtained from the real parameters. With B is base, TS are thermostat and sensor, motor, H is heater. Motor power is 0.6 kilowatts and 1.6 amperes. Current in each phase is 17 amperes. Total length is 3,780 millimeters. Total height is 1,250 millimeters. Total height is 200 millimeters. Transition process during drying. In the wetting method, the product is removed during the process, wetted, and placed back in for drying. This disrupts the process and correct data cannot be obtained. The graph is necessary to create a mathematical model that simulates the real process without the need to run the dryer, as well as to make a forecast for the process. Method for recording the temperature of the transient process through a monitoring system has been proposed. The devices and software used are from microsystem sensor transmitter with output 0 to 10 volts, data logger with 4 inputs with 0 to 10 volts, a USB converter 485, software MSDL-net 3.02. Figure 2 show block diagram of the temperature monitoring system. Results: humidity measurement by weighting method. Figure 3 show the change in the weight of the tested product during drying within 2 hours. Data for the first hour are taken every 3 minutes and for the second hour every 6 minutes. They are data only for the from average shelf, the first column of the dryer. Product weight measurements are performed with a Kern AWJ 330 TH electronic laboratory scale with an accuracy of 0.001 gram. Figure 3 show weight change during drying of the red beet rod. The net weight of the product before drying is 25.44 grams with an initial measured content of 86.08%, and after drying the net weight is 3.323 grams with a final measured content of 7.36%. The instantaneous humidity can be determined considering the following MT equal to MW plus MDS, where MT is the total mass of the beet, MW is the mass of the water, MDS is the mass of dry matter. From the measured humidity of the material, it is found that the water in the product 21,898 grams. To calculate measured content, we use MI, which is the instantaneous total mass measured by balance. Figure 4 shows variation of humidity as a function of the time. Figure 5 shows page model with MR real, MR lin, MR nonlinear. Coefficient for M-lin and N-lin and MK non-lin in N non-linear. Obtaining the graph of the transient process during drying, the temperature recording is carried out with the monitoring system every 10 seconds. Figure 6 shows the temperature change in the first column of the dryer during the process. The net weight of the product before drying was measured to be 45 grams with an initial measured content of 81.11% and after drying to be 3.705 grams with a final measured content of 11.05%. Figure 6 shows air temperature of the dryer during drying. Conclusion: the emphasis of this work is focused on the study of the transient process during drying of the red beetroot product. From the data obtained in the by weight method, a graph of water evaporation from the product was obtained. The created 3D model of the dryer can be used to predict and study the movement of airflow in the facility. The data from the temperature graph, a mathematical model, can be created in Simulink describing the process, which can later be used for student training. Thank you for your attention.